Welcome to the lecture series. In this series, we are going to discuss about the embedded systems and programming, and we are going to discuss real-time embedded operating systems. And introduction to RTOS is OS, that is an operating system that processes the data as an event occurs, and it gives the strict time constraints, manages the hardware resources in the embedded data. So we can have the pictorial or draft here is RTOs. It has the network protocols, file systems, other components, and which supports the libraries, and it has the POSIX and device drivers, debugging facilities. So these are the applications, and it has the components. So key characteristics is it is a deterministic behavior, low latency, priority based scheduling, and minimal memory footprint. So importance is it is critical for the time sensitive application and ensure system reliability and safety, enables precise control of the hardware. So the two main thing is it performs the task depending upon the priority. So it is the not suitable for the insensitive cases. So next is hard real time as critical deadlines. So here failure to meet the deadline is equal to system failure. So here we are stating a system failure, predictive execution times, and it is mainly used in the flight control and medical devices. So basically we have hardware real time, soft and firm real time RTOs. So depending upon these three types, we know hard RTOs is nothing but the if the deadline is failed, the overall system is failed, and it can be used in the flight control and the medical devices, which is the critical conditions. And soft real-time operating system is reduced utility. So here the performance degrades with the missing deadlines and can be used in the multimedia and gaming systems. So if the performance is lagging, it sometimes loses with the missed deadlines. So next one is result useless. Here Prim real time is result useless after deadline. So if it comes after the deadline, the result is very useless and can be used in the financial trading and the data acquisition. So I'm just giving the three examples for it. Hard real time is medical devices. So if in medical devices, if the deadline is not met within the time the report is not generated or the result is not given, it is useless to treat the person after the patient gets failure. So the deadline fails means the overall system gets failed. It is very crucial. Whereas soft real-time operating system, it is a gaming. So when I'm playing a game, there may be a lag. So due to the lag, the deadline may be given to me. So my phone may be getting lagged, but the timer is keeping on going. So the performance may be lagged, but deadline has to be met. If the both is not met, I may lose the game. And next one is totally opposite, where if the deadline is within the deadline result is not shown, I may lose the overall. So in the financial trading and data acquisition, on time the data should be fed, it has to be analyzed, and the action has to be taken. Next one is empathize, understanding the user needs. So empathize is we have to understand the user needs. So first, why we go for RTOs is to ensure whether the requirements of the real-time world is acquired. So timely task execution, determined minimal latency, efficient resource. So these has to be attained by the RTOs. And where we have to focus is performance, resource constraints, and reliability needs and development needs. So these are the 4 areas we have to focus on. And next is how we define RTOs is we just get the data from the sensors, having the input conditioning, we have the input interface, with that we give to the real time, and from the real time we get the data we get for the signal conditioning, and after that depending upon the signal condition we give to the output to the actuators to perform. And ideal So we know the process of the real-time system, right? So depending upon, we can choose the components, we can go for the application works. And before we going for application, we have to focus on the priority scheduling, memory management, synchronization, and hardware abstraction. So these are the other four things we have to focus on before going for the prototype. So in prototype, we have to focus on the applications, but we have to choose the RTOS kernel and libraries also. So kernel prototype is core scheduler implementation. So what type of kernel we are choosing is also important, and memory manager is very important because allocation delocation system has to be managed mutually. And IP is the inter-process communication. Inter-process communication lags means the overall system get fails. And next one is device driver framework. Yes, since it is a multiple tasking, it has to be very conscious on the driver systems. So testing is the another need we have to get for the testing. First, we are concentrating on the hardware, central processing unit. We are having the interrupt control and time management. And coming to the kernel space, we have input output management system, memory managed, task scheduling, task synchronization. All these will be controlled by your kernel. And coming up from the out world, we have the software application where the user has the interactions. So in the testing, we have to evaluate the performance, measure the time constraints, and refine the test results. So what methods we use is stress testing, time analysis and measurement, interrupt latency testing, resource utilization monitor. So key components of RTOS here is, we know kernel, scheduler, memory manager, device driver. So these are the four important core components used in our RTOS. So this is the pictorial representation of the hardware and software real-time RTOS. And coming to the RTOS in a script, we can take it as multitasker, scheduler, precise timing, it manages the memory, its reliability, and task communication. So these are the 6 main components where the RTOS perform. Coming to the multitask, it is ready, running, waiting, interrupt conditions. And scheduler, it gives the primitive and non-primitive. Precise timing means it gives the hard timing and soft timing. Memory management carries out with the events, queues, mailbox, and pipe. And task communication is shared data. It goes and deals with the shared data and task switching and interrupts. And again comes under with the priority, deadlock, mutex counting, and pinlock. So these are the basic terminologies you have to know about the real-time embedded systems. In next lecture series, we will discuss the architecture of the RTOS in deep, and with the help of that architecture, we will develop an application with it. Thank you.